Hi all, I'm so excited to be part of KCD Pakistan today, and I want to thank the event organizers for giving me this opportunity to share my talk on CACD best practices with all of you. So, without further ado, let's continue with our further talks. So, here is little bit about me. My name is Siddesh, but you can call me Sid or Sidhu if you like. I'm a technical lead at Wipro with a passion for cloud technologies and DevOps. I am a Google Cloud certified architect and DevOps engineer, which means I'm always up to date with the latest developments in the field. In fact, recently I had a chance to speak at GDG London 2022 event, which was an incredible experience. My approach to technology is all about making it fun and accessible to everyone, with a healthy dose of humor thrown for a good measure. In my free time, I play video games, watching Netflix, and spending time with my family and friends. And of course, I love attending events like this, want to connect with other like minded professionals and share our experiences. Now that you know a bit more about me, I'm excited to jump into the main topic today, that is CACD best practices. So let's get started. So, what is CI? CI stands for Continuous Integration. Continuous integration is a software development practice in which developers merge their changes to the main branch many times a day. Each merge triggers an automated code build and test sequence which ideally runs in less than 10 minutes. A successful CI build may lead to further stages of continuous delivery. We will talk about continuous delivery in few minutes. So, if a build fails, the CI system blocks it from progressing it into further stages. Then team receives a report and repairs the build quickly, typically within minutes. Then again the build will be started. So all competitive technology companies today practice continuous integration. By working in small iterations, the software development process becomes predictable and reliable. Developers can iteratively build new features. Product managers can bring the right products to market faster. Developers can fix bugs quickly and usually discover them before they even reach to users. So, continuous integration requires all developers who work on a project to commit to it. Results needs to be transparently available to all the team members and build status reported to developers when they are changing the code. In the case main branch fails to build or pass the test, an alert usually goes out to the entire development team who should take immediate action to get it back to a green state. So, now let's talk about CD. So, what is CD? So, CD, so it stands for continuous delivery and continuous deployment. So, let's talk about continuous delivery now. So, continuous delivery builds on the foundation of build and test automation established with continuous integration. With continuous delivery, you can turn the manual steps used to release a build of your software to production into an automated process. Whereas in the past, there may have been a handoff from your developers to testers and then from testers to release managers. With continuous delivery, your team, which may include people from range of disciplines, owns the entire process of building, testing, and releasing their product. This comes with several advantages. So this avoids a traditional silos. Your development team has better understanding of the business and operational needs for delivering their product to your users. In turn, this creates an opportunity to bring development practices to what was typically a manual and often quite lengthy process. Automating the steps involved in delivering a product to live not only speeds up the process but also reduces the risk of errors and makes it more stable and reliable. So, following are some of the key benefits of continuous integration. Early detection of conflicts. CI helps to detect conflicts and integrate code changes early in the development process, reducing the risk of integration issues and making it easier to resolve conflicts. The second one, improved code quality. By integrating code changes regularly, CI helps to catch and fix bugs and issues early in the development process. This leads to higher quality code. Third one, faster feedback. CI provides faster feedback on the quality and functionality of the code changes, enabling developers to quickly identify and fix issues and get their changes to production faster. So, the fourth one, increased collaboration. CI encourages the collaboration between developers by making it easier for them to share the code changes and collaborate on the development processes. This leads to a more efficient and streamlined development processes, reducing the risk of delays and ensuring that changes are delivered quickly and reliably. Let's move on and see some of the key benefits of continuous delivery. First one, faster time to market. Continuous delivery automates many of the manual steps involved in deploying code changes, enabling organizations to quickly deliver new features and bugs fixes to their customers. The second one, improved reliability. By automating the delivery process and subjecting the code changes to rigorous testing and quality assurance, continuous delivery helps to ensure that changes are delivered reliably and with minimal risk of failure. Better collaboration. Continuous delivery encourages collaboration between development, testing, and operation teams, enabling them to work together more effectively and efficiently to deliver code changes. Increased agility. Continuous delivery enables organizations to respond quickly to changing business needs, making it easier to develop or deliver new features and enhancements and to quickly address customer needs and concerns. This increased agility helps organizations to remain competitive and responsive in today's rapidly changing business environment. So, let's talk about some of the key benefits of continuous deployments. Increased efficiency. By automating the deployment process, continuous deployment helps organizations to eliminate manual steps and reduce the time and efforts required to deploy the code changes. Faster delivery of new features. Continuous deployment enables organizations to quickly deliver the new features and enhancements to their customers, improving their time to market and helping them to stay ahead of their competition. Better alignment with DevOps goals. Continuous deployment is easily and closely aligned with DevOps goals of improving collaboration, efficiency, and speed of the software delivery process. By automating the deployment process, continuous deployment helps organizations to achieve these goals. Improved ability to manage change. By automating the deployment process and making it easier to deploy code changes, continuous deployment helps organizations to better manage change and respond to changing business needs quickly. This increased agility helps organizations to remain competitive and responsive in today's rapidly changing business environment. So, till now we have spoken about continuous deployment and continuous delivery. So, let's also talk about the difference between these two. So, continuous deployment allows you to deploy changes to production automatically, whereas continuous delivery requires a manual approval before pushing the code into production. So, with this the feedbacks are often slow as this involves the manual steps of approval, but with the continuous deployments, feedbacks are very quick. Okay, now we got to know much about CI/CD. Let's talk about the best practices for creating a CI/CD pipeline for secure and efficient software deployment. First best practice is to commit early and commit often. Ensuring all your source code, configuration files, scripts, libraries, and all the executables are in the source control is an essential first steps towards implementing continuous integration, enabling you to keep track of every change. Each commit triggers a set of automated tests to provide prompt feedback on change. Committing regularly ensure your team works on the same foundations, thereby facilitating collaboration and reduces the likelihood of painful merge conflicts when integrating large complex changes. Next, keep the build green. By building the solution and running a set of automated tests each time a change is committed, a CI/CD pipeline provides rapid feedback to developers about their changes. The aim is to avoid building on bad foundations and keep the code in a constantly releasable state. Not only it is much more efficient to address the issues as soon as they arise, but it also makes it possible to roll out a fix quickly if something goes wrong in production. Build only once. A common misstep is to create a new build for each stage. Avoid it. Building the software for different environments risks inconsistencies being introduced and means that you cannot be confident that all your previous tests have been passed. Instead, the same build artifact should be promoted through each step of the CI/CD pipeline and ultimately released to life. Streamline your tests. Although CI/CD relies heavily on automated testing to provide confidence in quality of your software, that doesn't mean you should aim to test each and every eventuality. After all, the CI/CD purpose is to provide rapid feedback and deliver valuable software to users at a faster pace than the traditional methods. That means there is a balance to be struck between test coverage and performance. If it is taking too long to get test results, people will look for reasons and ways to circumvent the process. Run the tests that complete quickly first in order to get feedback as early as possible, and only invest in lengthier tests once you have a degree of confidence in the build. Clean your environments. To get the most out of your testing processes, it's worth taking a time to clean up your pre-production environments between each deployments. When environments are kept running for a long time, it becomes harder to keep track of all the configuration changes and updates that have been applied to each one. Over time, environments diverge from original setup and from each other, which means that tests that pass or fail in one might not return the same result in another. Maintaining static environments also comes up with a maintenance cost, which can slow down in testing and delay the release process. Using containers to host environments and run tests makes it easy to spin up and tear down environments for each new deployments. Using an infrastructure as a code approach, you can create all those steps. Instead, instantiating a new container each time ensures consistency and allows you to scale environments more easily so you can test multiple builds in parallel if needed. Once you have invested in building the reliable, fast, and secure CI/CD pipeline that gives you confidence in the quality of your builds, as you don't want to underestimate that effort by allowing the process to be bypassed for whatever reason. Skipping the stages of automated testing risks in introducing avoidable issues. While reproducing and debugging issues, it is much harder as the build is not readily available to deploy your testing environment. It is likely that at some point you will be asked to bypass processes just like this once or only this time. So you'll probably in a full firefighting mode at that time. But it is worth using a retrospective or post-mortem to understand the motivation behind it. Does the process seem too slow? Perhaps there are some performance improvements or refinements to be made. Is there a misunderstanding as to when it should be used? Yes, communicating the benefits of CI/CD pipeline can help bring stakeholders on board to avoid these kind of mistakes or demands in the next time when the roof is on fire. Monitor and measure your pipeline. As part of setting up your CI/CD pipeline, you probably implemented monitoring for your production environment to alert you signs of trouble as early as possible. Just like the software you are releasing, your CI/CD pipeline will also benefit from the feedback loop. By analyzing the matrices all collected by your CI/CD tool, you can identify the potential issues and areas of improvement. Comparing the number of builds triggered per week, a day, or hour provides useful insights of how your pipeline infrastructure is used, whether you need to scale it up or down, and when the peak cloud tends to occur. Tracking the speed of deployments over the time and monitoring whether they are tending to take longer can indicate when it's time to invest in performance optimizations. Statistics from automated tests can help to determine areas that would benefit from parallelization. Reviewing the test results to find those that are routinely ignored can identify potential for streamlining your test coverage. Make it a team effort. Building an effective CI/CD pipeline is as much as about team and organizational culture as it is about the processes and tools that you use. Continuous integration, delivery, and deployments are DevOps practices. They rely on breaking down the traditional silos between developers, testers, and operationals, and encouraging collaboration between disciplines. Breaking down silos gives team more visibility of the end-to-end processes and opportunity to collaborate and benefit from different areas of expertise. Maintaining the pipeline should never be a job of single person. By creating the sense of shared responsibility for delivering your software, you can empower everything on the team to contribute. Whether it is just jumping in and fix the build, taking the time to containerize the environments, or automating a manual task that doesn't get done as it often it should. So it should be always a team effort. So collaborate with development team and operational teams. Encourage collaboration between developers, testers, and operational teams. This helps ensure that everyone is on the same page and working towards the same goals. Last but not least, continuous improvement. Continuously evaluate and improve your CI/CD processes. This helps ensure that your processes remain efficient and effective over the time. So these are some of the best practices to build strong, secure CI/CD pipeline. Now let's talk about the diagrammatic view of CI/CD pipeline. Here is the pictorial representation showing the continuous integration, delivery, and deployment. Developer is pushing the code to source code repository, and a CI/CD server is building it and creating a container images, and those container images are stored in container image registry. So once the images are created, they'll be pushed to test or staging or production environments using the continuous delivery or deployment method. And this is how a typical CI/CD pipeline in a cloud platform. A typical CI/CD pipeline consists of several tools including a version control system, a CI server, and a package builder deployment server. For example, many development teams can use Git for version control as it provides a powerful and flexible way to manage source code. In the CI stage, a CI server like Jenkins can be used to automatically build, test, and deploy code changes as they are committed to version control system. This stage often involves the use of build tools like Maven, Gradle, as well as testing frameworks like JUnit or Selenium. When a code change is committed to the version control system, the CI server will automatically initiate a build and testing process. If the build fails, the automated pipeline will stop and a detailed build report will be sent to the developer who committed the change. This feedback loop helps to catch issues early in the development process and ensures that the high quality code is promoted to the later stages of the pipeline, such as testing and production environments. In the CD stage, the package builder deployment server can be used automatically deploy the build and tested code to various environments, such as test, staging, or production. Popular tools for these stage include tools like Docker, Kubernetes for containerization and orchestration respectively, as well as cloud providers like GCP, AWS, Azure, and others. Overall, a well-designed CI/CD pipeline can help development teams to deliver high-quality code faster and more reliably by automating many of the manual steps involved in the software development and deployment process. This example includes both information on the tools used in a CI/CD pipeline and the importance of the automated feedback loop in catching the issues early in the development processes. So here are the different tools used in stages of the pipeline. Some of them are famous and most used like Git, GitHub for source code management. Jenkins can be used for both continuous integration, Nexus for artifact repository, SonarQube for analysis, and so on. Finally, a targeted environments may be on-prem or any cloud providers that includes GCP or AWS or Azure. And that brings us to the end of my talk on CI/CD best practices. I hope you all found it informative and encouraging, and that you are leaving here today with some new ideas and insights on take back from your own teams. As we have seen, there are many different approaches to CI/CD, and each organization needs to find one that works best for them. But the key takeaway is that with the right tools, processes, and mindset, it's possible to deliver high quality software faster and more efficiently than before. Before I go, I want to thank the organizers of KCD Pakistan for putting me on this fantastic event and for giving me the chance to share my thoughts and experiences with all of you. And of course, I want to thank all of you for taking the time and listen to me today. And if you have any further questions or would like to continue the conversation, please feel free to contact or connect with me on LinkedIn using the QR code that I have provided. I'm always happy to chat with other professionals in the fields and share your experiences. Thank you all again and have a great rest of your day. Bye bye.